quantum theory describes the sort of world of atoms and subatomic particles. And at its heart is a huge mystery. And the history of the subject is that actually it began as an attempt to understand how light bulbs work and how to make light bulbs more efficient at the end of the 19th century. And we came up with a way of describing the atoms that would sit within the filament of a light bulb, describing them as waves and particles at the same time. So we think of our bodies as being composed of solid stuff, as it were. But actually, if you want a full description of how these things behave, you have to also be able to think of them in terms of the atoms in our bodies being waves rather than solid stuff, which is a very difficult thing to deal with. And this leads us to the idea of wave-particle duality. So that means that when we have something like an atom or an electron or a photon of light, which is the sort of quantum packet of energy of radiation, we can think of these things as solid lumps, or we can also think of them as being waves. And in fact, we see from the Schrödinger equation that I just showed you that actually they have these possibilities of what's called superposition. So the Schrödinger equation is a wave equation. It describes how waves work. And this gives us, good indications of what actually happens in experiments. So treating things as waves really does work. But actually, it also means that when you have something that's effectively like a wave, but also a particle, it means you can do strange things to it, and strange things will come out. So the double slit experiment is an attempt to expose this.